Hello, everybody. Hello, and good afternoon to you all. And welcome to this workshop on computer science fundamentals. So, today we are going to talk about, uh, at the high level, we're going to talk about how algorithms and data structures work at the high level. So, we won't do any coding exercises in this particular workshop. We won't get into, let's say, technical details. This will be more theoretical. All right, but let me set up the agenda for you and tell you why we want to look at things a little more theoretically. The reason is, if you do understand um, fundamentally how computers work, then you can work from first principles to solve any problem that have to do with computers, in particular application development and uh, writing software in general. Okay. Now, as I'm going through these slides, I want to encourage you to put your questions in the chat so that uh, towards the end, or maybe even halfway through the presentation, I can answer your questions because they may be related to what we're going to cover. Okay. Now, before I do, I just want to do a quick survey. If you're a tech person, if you've done programming before, just type in yes. If you haven't done any programming before, just type in no. And with that, we'll jump into the slides. And the first thing we want to look at are algorithms. Okay. Now, for those who are in this workshop because they want to know about the Koni Bootcamp, this is something we will talk about today, but at the end of the content. So stay tuned for that if you are here for that discussion as well. Okay. Now, computer science is a discipline that is originated from mathematics, and we can say it's half about mathematics and the other half is about technology. So data structures and algorithms is where, let's say, it's at the center of computer science. So in other words, if you want to be good at computer science, if you want to be a good problem solver with computers, if you want to be able to write and understand algorithms, even very advanced algorithms, for whatever purpose that is, maybe it's building mobile applications, maybe it's for machine learning, then you need to understand this very central um, area of computer science, and that is data structures and algorithms. These two go in hand in hand. So understanding these will make your learning journey uh, more, let's say, clear. And as you encounter different ideas, in your own learning journey, you will be able to group things mentally and be able to picture, let's say, let me rephrase that. You'll be able to navigate your way in this field of computer science, because technology is a big area, and there are so many resources. Sometimes it can get overwhelming, and I'm sure many of you have tried to learn app development, software engineering, computer science on your own, and maybe even data science on your own, and you may have found it to be like I said, overwhelming. Okay, but the goal here is to bring you to put your focus on the fundamentals, because once you know the fundamentals, once you know like what is computer science at the core, then you would be able to navigate your way, uh, you know, more easily when you're trying to learn anything that is related to computers. And we will start our discussion with algorithms. And to talk about algorithms, let me give you an analogy, and we will use analogies to explain this. And if I can ask everyone who's joining the session to keep your microphone on mute, so we can, so everything is clear when I'm speaking. Okay, so let me use this analogy to explain what an algorithm is. Let's say you have decided to upskill. You have decided to make yourself better in this year, and you want to learn uh, computer science. That's the topic of our workshop. How do you go about that? What are the steps that you will take to accomplish this goal of yours? You want to upskill. How do you do it? Number one, you'd find a skill that you could help you in your career, that can help you in your hobby, that it can help you in your let's say personal interests. So you find that skill. Then you start learning. You start learning the essentials, the basics, and then once you have immerse yourself in this field, your next goal will be to master these new skills. Okay. Now, what I'm trying to do here is draw an analogy uh, between how we humans think and act and how computers think and act. How would we break down these three steps that we're looking at in front of us right now? Find a new skill, learn a new skill, master a new skill. Let's say what we see on the left is what you're trying to is your goal, it's the algorithm of your goal to upskill yourself. If you take the first step, which is find a new skill, that particular step itself can be broken down into smaller steps. Let's say finding a new skill, the process of finding something to become skilled at it could involve something like what I suppose everyone has done in this particular meetup, which is go to meetup, find some interesting events that you might find helpful, check out the dates, uh, click the RSVP button, and then attend the workshop like you're doing so now. So step one here on the left itself can be broken down to smaller steps. So step one could be opening the meetup application, and then finding events, RSVPing, marking your calendar, and then attending. But even if you take the first step in here, that itself can be further broken down into smaller steps. So even like opening the meetup application on your phone requires several steps. First, you have to pick up the phone. Then you have to swipe the screen to unlock. Then you have to click on the meetup icon. And then you have to wait for the app to load. And then you see the search bar, and then you type in something. For example, learn how to code, learn how to cook, learn how to write. Okay? So my point is, the way we humans think is we have a big objective, but then we break that objective into smaller, let's say, tasks, and those tasks in turn can be broken into smaller tasks still. Computers work a similar way, and this following illustration will make this idea clear. So this is, you know, you may have seen something that looks like this is a function. It's pseudocode. It's not from a particular programming language, but this is what a function would look like in most programming languages. Okay. Now let's say we are talking about a piece of algorithm for registering a user on a website or an application. So you write this algorithm. Okay, it's okay if you don't know how to write algorithms in it, or you don't know programming languages at all. Just stay with me. And what we're trying to do here is like I said, establish the fundamentals, understand the fundamentals, and then from there we will get into, for example, what programming language you have to learn, how you have to learn programming languages, and so on. But let's say you've written this algorithm, okay, in, let's say, JavaScript or Python or C++, whatever. The steps in that algorithm, okay, the steps in the algorithm in turn will be broken down into smaller steps. And then those steps that you see here in the middle of in the center of the screen will be broken down into simpler steps still. Okay, so let's understand how computers work. By the way, you and I are, when we communicate, we speak with words. Okay, we communicate with words. When we want to talk to computers, we also use words. The words are written in a funny way, you know. If there's a special way of writing those words, but they're still words nonetheless. So, for example, here, even though if you don't understand the programming syntax, you can still make out the name of this particular algorithm, which is registered user. You can see it. Computers, the one with which you're watching this workshop right now, your phone, your tablet, your laptop, or any computer for that matter, they do not understand programming languages. They understand ones and zeros in the form of electrical signals. Okay, so the way we talk to computers is we write a program with a programming language, and that will be processed. Uh, those the particular steps in your in that program will be broken down into smaller steps, and then ultimately they will be turned into binary, which is something the computer can actually understand. Okay, so this is analogous to how we humans also operate. Okay, when you want to upskill, you don't even have to calculate all of the tiny steps you have to do, like moving your hand, pressing with your finger, I don't know, moving your elbow. These are, you do this at the subconscious level. It's not something you have to worry about consciously. Similarly, when you are writing programs on a computer, you don't have to worry about the process of taking the programming language to binary. This is done by the computer automatically. So what you need to really understand is this part. Okay, knowing how to write algorithms which are very similar to uh, how you think. Okay, now one more thing before we move on. What you see on the left here, this example algorithm, this is what we call a high level programming language, as opposed to, for example, what you see here in the setup, which is a lower level programming language. A high level programming language is a programming language that is very similar to how we humans uh, write. Okay, it's the closest thing to the written language. So if you're someone who wants to learn how to write software, you will find it easy to learn this particular uh, you'll find it easy to learn a high level programming language, because it's very user friendly, and you won't have to worry about things like, for example, assembly and binary. These are for people who are, let's say, computer engineers, and they're involved with computer hardware, and that's a very within the field of computer science, that's a very narrow field. And so if you're someone who wants to learn how to build an application, or how to work with machine learning, these are not things you need to worry about. You want to learn how to write a high level programming language, which, like I said, is very similar to the written language. And stay with me, and towards the end, by the way, I'll tell you uh, what steps you take next, and what kind of programming languages and that kind of thing. Now, like I said, very closely related to the idea of algorithms and writing algorithms and how algorithms work is this other concept called or this group of things we call data structures. So algorithms and data structures, they go hand in hand. Why is that? Well, let me explain by setting up this scenario for you. Every computer, that is to say, any computer that runs, that has that has a hardware and runs some sort of software. It can be an airplane, it can be an ATM machine, it could obviously your laptop, your iPad, your telephone. These are all examples of computers, and all computers, irrespective of what kind of computer they are, will have three main components. Some sort of processing unit, like a CPU or a GPU, a permanent storage, something where you can store information permanently, like an SD disk, an optical hard drive, CDs. I know they're obsolete now, but CDs are examples. Floppy disks, different USB flash drives, right? These are different types of, let's say, devices in which you can store data permanently. Okay, so you have a processing unit, you have some kind of unit for storing information permanently, and then another unit for storing information temporarily. Now, why am I talking about these three main components? Besides the fact that you should know how these works anyway, because these are things you need to know about. For example, when you want to purchase another computer or a laptop, you need to know what these how these components work, and understanding how they work can help you decide which uh, you know computer or phone to buy. But besides that, in the context of algorithms, data structures, understanding temporary storage, at least at the high level, is going to uh, help you become a better uh, computer scientist, or someone who wants to do computer science, someone who wants to write software. Okay, so we need to know what briefly. We need to know what a temporary storage is in order for us to understand data structures. So let's go back to that example algorithm. How they want the algorithm for registering a user. Okay, now this algorithm uh, must be written in a particular programming language: C++, Python, PHP, JavaScript, whatever. And it is in a file with its appropriate extension. So let's say this is a C++ code, for example. Okay, so the contents of this file are this are this is this program you see here on the left, the supposed program. There's a function to register a user, another function to log in a user. Now, two terms you need to be familiar with: program and process. Program and process. When you write an algorithm and save it to a file, which goes on to the permanent storage, like your hard drive or your flash drive or on Google Drive even, we call that a program. So when the algorithm is in the file, we call that file the program. Okay. When you boot that file, when you bring that file into the processing unit, that will become a process. So a program, when it's fed into the processing unit of the computer, is now called a process. Okay. Now, when you are, let's say, when the computer is reading the contents of the program. So for example, here we have program.cpp, program, which is, let's say, a C++ program. Algorithms written in C++, that's the program. When the computer starts to read the contents of the program, different, let's say, components of this algorithm will be put into the temporary storage. I'm sure you've all heard of the word or the acronym RAM, random access memory. Okay, random access memory is one type of temporary storage. Okay, so for example, when you open your when you open your laptop and you double click on a file, let's say program.exe or program.dmg, if you're a Mac user, what you're doing is you're pulling, you are reading you have the CPU is reading the contents of that file. Okay, and then turning into a process by creating some things. I don't want to get too technical, but putting some things into the temporary storage. In other words, the temporary storage is going to contain the data let me tell you specifically what they are, and then in the subsequent slides maybe I'll tell you what they are. So you will have function arguments, you will have local variables, you will have instruction registers, and return values of functions put inside the random access memory, or this computing unit for temporary storage. Bear with me and you'll know why this is important to know. Okay, so certain things that this algorithm does, certain elements that an algorithm needs to function, to work, to compute, those elements must be put in the temporary access, the temporary storage. Okay. In order for you to be able to read the contents, in order for you to be able to read the contents in the random access memory, you need to write, or before you write, you need to choose how you want to arrange and read the data in the temporary storage. Okay, let me go back to that slide. So let's say we're trying to register a user. We're trying to register a user. Someone types in their email address, they click on send, and what we want to do is take their email address and save it to the database. Okay. Their email address, for example, the date at which their account is created will be put in the random access memory. And the way the data structure will work, or the purpose of the data structures rather, is how you will organize the different data that is distributed by this algorithm. Let me take another step back and put it to you this way. Without data structures, you will not be able to read and operate with the contents of the algorithm. So for example, the email with which the user created their account, the date at which their account was created, whether their account was successfully created or not, their first name, their last name, all of these details, you will not be able to manage without this thing we call a data structure. Okay, so what you see here on the right in the temporary storage, these are all data. But they are not something you can access directly and in an orderly way. So you need some sort of thing that allows you to order these in an appropriate way. So, and this is what the following slide is about. Here's how to understand data structures. Before I talk about the slide, here's how to think about a data structure. Think about an Excel sheet. What does an Excel sheet look like? You have a bunch of columns and then a bunch of rows. So the columns, for example, can include, for example, the user's email address, their first name, their last name, their date of birth, the company at which they work. Okay, and the rows would correspond to a person. First row will be one person, second row with person, third person, third row will be another person, and so on. You obviously know this. So this Excel document, that is sort of the data structure. That is a structure that contains data. Okay. And by the way, that particular data structure, that this idea of having rows and columns, is how some databases store data. Not all databases, some databases, that's how they store data. Now, that particular data structure is obviously very useful. It's something we're all familiar with. It's intuitive. Maybe even a child can make sense of that idea of having rows and columns. However, that particular data structure may not always be suitable And so you would have to arrange the data in different ways depending on your needs. Now, I want you to look at this slide for a moment. Fundamentally, in computer science, we have two classes of data structures. So basically, two groups, or let's say two categories in which you can arrange data. Okay, there is one which is linear, okay, where order is an important thing, and there's one which is not linear, where the order is not the most important thing. Rather, it's how you map, how the data are mapped to each other. Okay, irrespective of which data structure you choose, and I'll tell you how and why you should, how and which data structure you should choose. But irrespective of which of these types you use, all of the values in those data structures are connected to, or are read from, the temporary storage I told you about. So, for example, if I go back to the slide here, when I said what I said, the user's email address, the user's first name, the user's last name, all of these are put inside this temporary storage. When you have a data structure, so if you you know what, even right now, if you have Excel sheet in front of you right now, as you're looking at those rows and columns, those values in those rows and columns are actually being read from the temporary storage. So when you're scrolling down in the Excel document, or when you're going from one page to the next, what you're really doing is you're pulling values from the temporary storage and assembling them so that they look orderly. Because in reality, those rows and columns, the values of those rows and columns are not actually ordered in a sequential way, the way you perceive them. Okay, so uh, between you and the data that is in your computer, there's a data structure which organizes, assembles things in an orderly way so that you can understand them. Okay. Now, which now you want to uh, uh, going back to the objective of this workshop. If you want to be a good software developer, a good programmer, a good software engineer, or a good computer scientist, you need to know the different data structures that are out there. Okay, that you need to know the different data structures that are out there. And I said there are fundamentally two categories: the linear kind and the nonlinear kind. Which data structure you should choose, you should know all of them, by the way, but which data structure you should choose will depend on your needs. So, for example, some data structures are ideal if you're simply going to add items to the array, you're going to add items to the data structure, but you're not going to try to add, remove, or move things around frequently. Okay. Other times you may, for example, your goal is not, for example, adding things to the data structure, but moving things around more quickly, more rapidly. Some data structures perform well when it comes to searching. So if you want to look for a particular value in your, let's say, in your data, some data structures will make it easier for you to find that data much more quickly. Some data structures, however, can uh, will not perform as well, just because of the way they are assembled. Okay, so for example, trees, if you heard of binary trees, it's much quicker to find data in a binary tree than a single array. Okay, in an array, if you do not know where your value is, you have to go from start to finish to find what you're looking for. Okay, so pros and cons. Now, you will not, obviously, you will not be limited to one particular data structure. You will be using different ones depending on your needs, and in fact, you will be using a combination of them. And in some cases, you would even make up your own data structure. All right. Now, uh, the next slide will help us understand uh, algorithms and data structures in relation to one another. And then after this, I will tell you what you should learn next after this workshop is over. So programming constructs fundamentally are the, let's say, the building blocks of uh, a programming language. Okay, so uh, we let me give you let me give you a simple definition for all of these three things we talked about. We talked about algorithms, data structures, and programming constructs. Algorithms, I told you, is just a sequence of steps. Okay, a sequence of steps. When we want to, for example, bake a cake, we have an algorithm. Okay, bring the flour, bring the water, bring the eggs, and then we break down those steps. That's the algorithm for creating for baking a cake. Similarly, computers also uh, perform tasks in a sequential way, and so that's the word algorithm. It's just a sequence of steps. And data structures are these things, these constructs that allow us to put data, take data from the computer, and assemble them in an orderly way. Okay, and assemble them in different shapes and sizes depending on the problem we're trying to solve. Programming constructs. Constructs refer to the building blocks, for creating an algorithm and creating data structures. Okay, so once you understood what the objective of an algorithm is, what the objective of a data structure is, how do you go about building an algorithm? How do you write an algorithm for a computer? How do you build a data structure? How do you write a data structure for a computer? You need you need programming constructs, right? If you want to write an algorithm for a computer, you need to know a programming language. If you want to have data structures for a computer, you can only accomplish this with a programming language. And if you want to write the programming language, then you need to know the programming constructs. Okay, just like in English we have, or any language for that matter, every language has a vocabulary and they have grammar. And uh, uh, their vocabulary can have verbs and nouns, and in the grammar they have different rules for putting these words together. Okay, and that's what the programming construct that's what we mean when we talk about programming constructs. Those building blocks for putting together an algorithm, and those building blocks for putting together data structures. Again, here programming constructs fall into three categories. There are programming constructs that allow you to write algorithms that are sequential. They go do step one, do step two, do step three, very simple. There are programming constructs that allow you to be selective. Okay, so for example, when you come across this condition, then do these steps, and if you come across that condition, do the other steps. Okay, so if you want to write an algorithm that does things depending on the situation, then there are also programming constructs for that. And then there are iterative, let's say, algorithms. There are algorithms that, for example, go from point A to point B to point C, and then when they reach point C, they go back to point A. So there are many applications where you would want to do something like this, where you want to iterate. So for example, let's say you have a database of users. Okay, like an Excel sheet. You have an Excel sheet full of customers, and what you want to do is, for example, convert every row in that Excel sheet into, let's say, a user's avatar on the application. So you would upload the CSV, and output you get, for example, a web page with all of the users of the application. You can actually do this in application development. You can upload a CSV file, and then that CSV file will manifest itself in the form of a page where you have, for example, the person's profile picture, their first name, their username, and then even a button where you can, for example, follow them or like their post. You can do this. So iteration is how you do this. Basically, you iterate over all of the people in the Excel document, and for every person in that Excel document, you will output, let's say, a piece of code corresponding to their avatar, to their profile picture. So, for example, if you think about Facebook or Twitter, you know how you scroll down, as you scroll down your phone, you see different posts. Those posts are connected to some kind of data structure, like the rows and columns that you see in an Excel document. So there are programming constructs to also facilitate this, uh, uh, you know, iterative, uh, iterative processes in an algorithm. Okay. Now everything I'm talking about is very abstract, very high level, and that's intentional. Okay, so stay with me, and you'll know why we want to stay at the high level for now. Okay, so when you, after this workshop, or even probably now that you're learning, you may be learning programming right now, or maybe you may want to learn programming at some point in the future. What you want to know is that no matter which programming language you choose, okay, no matter what problem you're trying to solve with software, everything that you find about a programming language, everything you find about a programming language will fall under these three categories. Either it will be something about sequential processing, it may be about selective processing, or it might be iterative processing. So knowing this will help you more quickly and more easily learn how to write software. Okay, so let's look at some of these. So sequences, selections, and iterations, these are all facilitated by these building blocks. I want you to look at these items. You can even take a screenshot of them, take a note of these. Everything you will come across in any programming language, anything that you will come across in any programming language will fall into one of these blocks. It will either be a function, a variable, a constant, some sort of control statement, a data type, or something we call classes. Okay? So if I go back up again, if your algorithm is going to have any of these patterns, if you want to implement any of these patterns, it is these constructs with which you will make that happen. If you want to write an algorithm for registering users, if you want to write an algorithm for uploading files, if you want to write a machine learning algorithm, if you want to build data structures in the form of rows and columns, if you want to build data structures in the form of binary trees, if you want to build data structures in the form of, I don't know, graphs, for example, if you think about how Google Maps works, or how any mapping system works, they use graphing data structures. If you want to build any of these things, they will be built with these uh, building blocks. They're just like Lego blocks. You know how with Lego blocks you can create ships, you can create buildings, you can create houses. Same thing with programming. With one of these items, you'll be able, with a combination of these items, you will be able to write any kind of algorithm to solve any kind of problem, and to write any kind of data structure to store data and process data in any shape or form that you want. Okay, so uh, you when you are learning programming, you want to make sure you've covered all of these, especially as a beginner, the first five. The sixth one, which is classes, you can do this once you have acquired enough skills. You have quite enough knowledge with the first five. Okay, but it's important for you to know that uh, this is it. These are the building blocks. Whether it's Python, whether it's Java, whether it's Ruby, whether it's JavaScript, all programming languages will have these same programming constructs. Now, uh, I invite you to put your questions, because I will open the next I'll tell you what to do with the next steps, and then in the next 5-10 minutes, I'll also try to answer any questions you have about what we talked about here. So, okay, I also want to give you the opportunity to interact with me. But here's what you want to do going forward. Okay. Now, obviously, you can go to YouTube and learn about these things in more detail. Like actually, like immerse yourselves. Like learn how functions work, learn the different data structures, and learn, for example, big O notation, and learn, for example, the different programming languages. So you can do that. But the next steps I'm going to suggest are assuming you already know about those things, and you want something a little more organized. So first, we have a Slack channel where all of these workshops, the content, the resources in these workshops are going to be shared. So these slides for this workshop and the previous workshops, they will all be put there. And if you have any questions about this workshop or previous workshops or anything we talked about here today or anything in general, this is where we can have those follow-up discussions. Now, we've also curated some YouTube videos. So if you're someone who wants to learn how to, for example, build apps, or even if you're someone who's doing a computer science degree, and you want some quality content, we basically curated some video content. Some of it are the videos that we produced here, like one of these workshops that that we do every now and then, and some of these videos are actually curated from different YouTube channels. So we prepared those, we put those on the Slack channel so that we can watch them and learn. You can learn on your own. And then the third one is, of course, something we talked about before, and that's the Koni Bootcamp. So this is if you're a little more serious about getting into coding. Let's say you want to learn programming so that you can, for example, let's say switch to a new switch your careers. Let's say you're in marketing, you're in sales, you're in, let's say, I don't know, IT, and you want to enter the software development profession. Or no, you have a business idea and you want to turn that business idea into an application. Okay, so for example, in the previous workshop we recorded 2 weeks ago, we talked about how to take an application from prototype into production. So if you saw that workshop and you say, you know what, I think I want to convert my idea into an application, well, then the Koni Bootcamp, this is what we prepare you. We prepare you. Now, before I talk about that, before I get into the Koni Bootcamp, I want to open up a 5-minute, 10-minute window to answer your questions if you have any. I see a comment here from Christina. He said, I tried to get in contact with you, but I didn't receive any response from you. Christina, I'm not sure where you tried to reach out, but I will follow up with you after this workshop. I'm not sure where you reached out, but I want to encourage you to ask your questions. For example, how many of you have any programming background? If you have a programming background, type in yes, otherwise type in no. So N says he has experience with programming with databases, SQL. Right. So, for example, if you want to obviously, when it comes to building applications, maintaining applications, databases obviously are an important component of the entirety of the application. And if you want to work with databases, then of course you need to know, especially how data structures work. But does anyone have any technical questions? Any technical questions in particular to data structures, particular to algorithms, particular to programming languages? Now, speaking of programming languages, you can type a question while I make this point. If you don't have a background with programming languages, then there are some programming languages that are preferable over others because of how easy they are to learn and how easy they are to get started with. So, for example, if you have no coding experience whatsoever, then a good choice would be to either start learning Python or programming language like JavaScript. Why? Because Python and JavaScript, uh, it takes very little to write a program and then turn it into a process. If you remember the slides we talked about before, it doesn't take much to turn a program into a process. Even with JavaScript, it's simpler still. You can literally turn to your browser. There's something called a console panel. Open up the console panel and you can start writing uh, JavaScript programming language immediately. You can start doing algorithms, data structures immediately. And JavaScript is particularly good because it can act as a bridge to, let's say, more difficult programming languages. For example, C++ is obviously is one of them, but even something like uh, R, or let's say uh, Haskell. You know, these are these are programming languages that require you to know those programming constructs really well before you can work with them. Or even Java, for example. If you want to learn Java, if I can go back up here in this previous slide, if you want to learn Java, you absolutely need to know this sixth construct. So you actually need to know this uh, in tandem with the others. Whereas in JavaScript, you can get away without knowing classes. Okay, but irrespective of which program you choose to learn, because they all share these same constructs, you'll be able to transfer your skills or apply your skills to learn another programming language. So, for example, if you're a Java developer, if you're a Python developer, because you have existing knowledge, because you already know about functions and variables and data types and so on, you'll be able to apply those skills to learn other programming language. Because, like I said, all programming languages have the same programming constructs. Now, I see a question from Ajara. He says, I'm learning JavaScript at the moment. In your opinion, is it good enough language for the backend? Is it good for backend development or not? Okay, so let me talk about JavaScript here. 2 weeks ago, I think it was 2 weeks ago or before that. But one of those workshops we recorded recently, we talked about which programming language you should choose for building an application, and I gave 3 examples. I talked about I think I talked about Dart. That it's a new programming language called Dart, and I mentioned JavaScript and C Sharp, with respect, which was in the context of a platform called Xamarin. So here's what I said, and Jared, this will answer your question. Some programming languages are um, more have more specific use cases. Some programming languages are more general use. So, for example, Python is an example of a general use programming language. When I say general use, I mean you can use this programming language to build anything from a web server to a machine learning algorithm. In fact, Python is used extensively in data science and by extension, machine learning. And it's even used, for example, in some cases, building desktop applications. But then you have a programming language like R. R is just one letter. It's a programming language that is confined to one application called RStudio, and it's used exclusively for statistical applications. Like you cannot use R to build, for example, a mobile application. Then you have an application like C++, which is one of the it's a language that has been around for a long time. It was one of the it's like one of the early programming languages, and it's used for programming things like ATM machines. Even airplanes are programmed with either C or C++. IoT, for example, if you think about electronic devices that are connected to the internet, those are programmed with C++. But then you have a programming language. Now, JavaScript is quite unique. JavaScript, in fact, this is relevant to the Koni Bootcamp, which I will come to in a second. JavaScript today has a very special role. It has a special place, and it is capable of doing something that the other programming languages are not really able to do. So, for example, C++ is considered a general purpose language. Python is considered a general purpose language. JavaScript is also a general purpose language, but now it has been able to cover all of the different platforms. Let me say what I mean by platform. When I say platform, I mean, for example, a mobile device, a laptop, an iPad, an embedded system, a smartwatch, let's say a smart pair of, let's say, headphones, fridges, coffee machines. These are all platforms, right? These are all different computation devices. Now, JavaScript historically was used for building web pages, not even web servers, web pages. Like, for example, the UI of a website. It was not used for anything else. It was confined to the web browser, just like how R is confined to just doing statistics. JavaScript was confined to only simple interactions on the web. Now we have, then sometime in 2014, 2015, this application was introduced, this program was introduced to the world of programming called Node.js. And Ajara, I'm sure you may have heard of this. Node.js, if I can take you back the slide here. If I can bring you back the slide over here. Remember the slide where I said you write an algorithm and then ultimately it will be transferred into binary? Well, obviously this goes for all the programming languages. All programming languages will be written in the high-level language, and the computer starts to convert it ultimately to binary. Node.js does this for JavaScript. Node.js does this for JavaScript. Before, it was only web browsers that could do this for JavaScript. It was the only way that you can go from a high-level language to binary was to feed your JavaScript to the web browser, and the web browser had limited features. For example, you could not use web browsers for building games. You could not use web browsers for building mobile applications. Okay, web browsers were designed for simple documents, simple web pages. But as the web browsers matured, as computers matured, as software matured, hardware matured, browsers became more and more capable. And then Node.js took this capability, took the capability of web browsers and the ability of going from programming language to binary, and made it so that you can write or convert to binary, not just for the web browser, but for any platform. This is a very important point. Anywhere that you can install Node.js, you'll be able to write you'll be able to program that computer. So if you can install Node.js, for example, on a mobile phone, okay, if you can run Node.js on a mobile phone, indirectly at least, then you'll be able to use JavaScript to write applications on the phone. If you can run Node.js on the desktop, which obviously you can do, then you can use JavaScript to build desktop applications. So, Ajero, I hope you can see where I'm going with this. So basically, Node.js is this application that you can actually install on any platform. And because you can install it on any platform, you can, in fact, use JavaScript to program those platforms. So we even have robots that are programmed with JavaScript. We have mobile applications that are written in JavaScript. Even machine learning. Machine learning is done with JavaScript. Some of you may have heard of TensorFlow, TensorFlow.js. TensorFlow is a machine learning platform, and you can write machine learning algorithms use JavaScript. This is something you definitely want to check out, especially if you're new to coding or if you're trying to experiment with different platforms, different programming languages. JavaScript will be an excellent investment in your future software career or your business endeavors. Now, let me come back to Koni Bootcamp. Okay. Now, if you're someone who has been, let's say, considering becoming a programmer for a while, and you've kind of been on and off, or let's say uh, maybe this is your first time that you're learning program and you want a structured program, then maybe the Koni Bootcamp is something you want to consider. The Koni Bootcamp is something we designed. It's a program we designed since 2017. We now have almost 400 graduates. And here's how the program works. It's a 2-month program designed for people who have no programming experience whatsoever. Now, those who do have a programming background uh, are able to appreciate the contents of this bootcamp because of their existing knowledge. They're able to move through things more quickly. They're able to get into more advanced topics more quickly. But at the same time, people who have no experience whatsoever uh, will be able to progress in such a way that they will start the bootcamp not having written a line of code, but by the end of the bootcamp, they will have completed a full stack application written in JavaScript. So everything we talked about in this workshop, data structures, algorithms, programming constructs, all of those are covered. Those are some of the things that are covered in this bootcamp. In addition to those important fundamentals, we also talk about the different technologies, the trending technologies. So once you learn the fundamentals, then you want to learn the specifics. You want to learn specific technologies so that you can build uh, applications, right? And our goal here is to teach JavaScript because JavaScript allows you to build an application on any platform. So the focus of this bootcamp is this really powerful programming language. So we will teach you the basics. We will teach you the basic programming constructs. Then we will progressively teach you different technologies, how to use those different technologies, and and ultimately you will have completed an entire application built on this programming language and related languages like HTML and CSS. So all of the components that you would need to build an application from scratch and put it online, the front end component, the back end component, the database component, all of these are covered in the uh, are all covered in the coding bootcamp. Okay, even though it's called coding bootcamp, we even talk about uh, the fundamentals that we talked about today. So we talk about APIs, for example. That's not listed here, but we talk about how to write APIs. We talk about, for example, let's say uh, uh, UI systems. So there's so many stuff. There are so many topics that are advanced that we cannot even get into unless we've covered the prerequisites. Because today, application development has become, uh, in particular, web development has become very complicated. So if you're someone who's trying to learn this on your own, it's not impossible to do, but because of the plethora of information out there, it's not easy to navigate your way around this. And that's exactly what this program is designed for. So I see a question here from Drew. He says, or she says, so we can either progress, to become a software developer or software engineer, whichever is correct, because most people want to be developers, not necessarily engineers. Uh, uh, so, well, there's two things that we need to talk about in your question. First of all, the fact that sometimes people use software developer and software engineer interchangeably. To keep things simple, I will also use these two words interchangeably. Yes, this program, even though it's called coding, is actually going to teach you how to become a software developer, in particular, a software developer for the web platform. But like I said, because you're learning JavaScript, because you're learning Node.js, and Node.js allows you to write applications on any platform, you will be able to effectively, by the end of this bootcamp, become a software developer for any platform. Let me say that again. This Koni Bootcamp will take you from zero to a point where you can run applications on any platform. So do check that out, and don't forget to join our Slack channel where these slides will be shared. The playlist I talked about, we've curated a playlist for you to watch, so you can take your learning journey to the next level. And of course, where we can have discussions about what we talked about here today in the past workshops and the upcoming workshops that we're going to be hosting very soon. Okay, everybody. So,
Thank you, Danny.
yes, if you can, yes.
Perfect.
Anuradha is going
Hi,
to jump here.
everybody.
Yeah.
My name is Anurad. So, just before we wrap everything up, I just wanted to quickly take you through what at Astral Labs do we. I mean, Danny obviously spoke the major part about the coding bootcamp as to how insightful and how resourceful it is, even though it's spread across 6 weeks. But then, like, you come in as someone who has absolutely no idea, but then you walk out with a very deep and a thorough understanding of how coding works. Uh, we do a whole bunch of things at Astral Labs. So the four different major topics that we cover under the umbrella is, number one, we help companies start the businesses in Dubai by getting the licensing, and in Saudi as well with the licensing, and obviously the co-working space that we have in GLT. Apart from that, one of the things are the Open Academy. So the meetup that we all attended today. So that's one part of it. Then we do corporate trainings as well. So if your company is looking for elevating your training modules, or to basically ensure that you're up to date with the trends, in be it in digital marketing, be it in coding, anything technical as per, we do that as well. Apart from that, the fourth thing we have started called the Astral Labs Talent, which is basically we help the recruiters connect to the right talents, and the right talents to the recruiters, vice versa. So this helps you find the hidden gems, I would say, I put it like that, in the markets, and then obviously to make the most out of it. So what I'm going to do is I'm also going to put a quick link in the chat where you can just quickly put in your details if there's anything that you'd like to know more about Astral Labs, about the webinar that you just attended, or if you're definitely interested in the coding bootcamp, or wanted to know about the other trainings that we do. It's pretty easy. Just leave in your details, and one of us from the company will get in touch with you.
Yes, definitely. So we do have and by the way, we do. If you are interested in joining the bootcamp, we have an upcoming. The next cohort begins on January the 20th. So the sooner you complete this form, the sooner we'll be able to get in touch with you and help you begin in a timely fashion. So I look forward to seeing you in the upcoming workshop, and of course, if you are going to join the Koni Bootcamp, I definitely look forward to seeing you there. But that's it for today. I want to thank you for joining us. Enjoy the rest of the evening, everybody, and until next time, take care and bye bye.